So here's the electrostatics worksheet. I went through and solved it. Key thing here is thinking about the electroscope demos. We did these last week on Friday. So if you're here Friday, you should be able to at least remember what that looks like. If you need other demos, let me know. I made a video of that for my AP Physics C class as a refresher. So maybe I might just post that anyhow. So the idea here is if you have something and let's say it's a negatively charged something, you bring it close, you bring it up to the top part here. It's positively charged the same way. So initially the electroscope is neutral. That's what I tried to show here in E. I didn't do a very good job of it because I showed positives and negatives in each place. I should have just left it blank. At any rate, if you bring something charged close but not touching, it can cause the electroscope to polarize, meaning that the charges separate. So for example, this situation would be caused if this green rod was negative, the negatives would repel to the bottom and the top would be left with a net positive charge. If this was positive, I'll switch colors for dramatic effect. Oh, I switched to red. That's usually a det. I'll go to blue. And that's positive, then if you look at D here, oh, I actually already had that drawn. The negatives would be attracted to the top and the bottom would be left positively charged. Now, in B and C, those are only going to have a net charge if they're touched. So if this is a positive rod and it touches the electroscope, which is made of metal, the whole electroscope will gain a positive charge. If it touches the electroscope and it's negative, the whole electroscope will gain a negative charge. So that's the idea behind that. This should be pretty easy if you understand that a proton and an electron has the same amount or magnitude of charge, just opposite charge, so 11 protons, 11 electrons. If you have a positive charge here and negatives on these things, you end up having it attracted down and to the left. This, I kind of drew it over here. If you have the negative rod coming close to two spheres that are neutral, they'll become polarized. And if they're metal, that's why they can become polarized, because the charges can move from one side to another. And so the left side becomes positive, the right side becomes negative. If they're separated, that's why the left side's positive and the right side's negative. Notice that overall things are still neutral because this negative has not touched the spheres and therefore they aren't gaining a negative charge. This was from the notes that I'd given you. So if that's the 1 coulomb is the charge on that many electrons or protons, the reciprocal of that would be the charge on 1 electron or proton. Coulomb's a lot of charge. For this one, when we look at this, this is really one piece of metal that I've basically split into 3 parts, A, B, and C. So because it's metal, the charges can conduct throughout it. I've got a rod here on the left end that's positive, a rod here on the right end that's positive. So obviously opposites are attracted. So the piece at the left end here, A, becomes negatively charged. C becomes negatively charged. The positives are repelled to as far away from either of the ends as possible. So B gains a positive charge. Ha! These answers were bad. 12 and 13 are using proportional reasoning. Again, I've made videos about that. Hopefully you can look at those. And they're going to be looking at the fact that if we look at Coulomb's law, we have a constant, charge 1 times charge 2 over the distance squared. Well, before we change anything, the easiest way is to think of each of those as 1. In this example, each of the charges doubles in magnitude and the distance between them gets closer. So that's by 3 times, so that's a third as far away. So I'm left with 4 in the numerator and 1/3 squared, or 1/9 in the denominator. 4 divided by 1/9 is 36. So the force is 36 times as much. Did the same thing down here. It's a little annoying because there's fractions. 1/2 is the numerator. 1/4 squared is the denominator. So it's a half divided by a quarter. So essentially it's 8 times the force. 8 times that amount of force would be that much. PC7 and PC8 are down here. Those are on the physics classroom calculator pad. If you need a little bit longer verbal answer. Shout out to Physics Classroom, by the way. They're allowing me to pilot version 2.0 of their concept builders, which means you won't have to send me screenshots after spring break. So that's cool. At any rate, here, Coulomb's law, the constant is always 9 times 10 to the positive ninth. Charge 1 times charge 2 over the distance squared. Notice I'm using standard units here, meters, not centimeters. Same way here, meters, not centimeters. So basically, this is just an algebraic rearrangement. A little bit of a pain in the butt, but I want to give you at least a couple examples to do that. If you have other questions, send me a remind. Have a great day.